Great morning, mini mathematicians, or afternoon. I'm so happy you could be here. We're going to finish up 6.1a lesson, square areas on Desmos. So this is our lesson purpose that we wrote down last time. Please pause the video for 1 minute for students to get onto their Desmos 6.1a and on to slide 15. We're going to start on slide 15. Please pause the video for 1 minute. Thank you. So I know we already finished on our slide 15, but let's review this just because it's really important to remember that square roots and squaring are inverse operations. They're going to undo each other. The way that we can pull a base or a term out of the radical symbol is if it's being squared, because they will cancel each other out. If we have a square with an area of 1, that means its side length is the square root of, that's right, square root of 1, which is 1. If you have a side length that is 2 units, what do we do to a side length to get the area? That's right, square it, and that's how we get 4 units squared. If we look at the next one, if our area is 3, how do we figure out the side length? That's right, we just take the square root of the area. This is an irrational number, square root of 3. It's the square root of a non-perfect square. That means it's a non-terminating, never ends, non-repeating, never repeats decimal. So we want to leave it as a square root of 3 to be as exact as possible. So let's take a look. The next side length is the square root of 13. Well, what did we do with the other side lengths to get to the area? We squared them. If you take the square root of 13 and square, that means that you end up with 13. Because square roots and squaring are inverse operations. Wonderful. Taking a look, your side length is 20. What does that mean for your area? 400 square units. Your area is x. What does that mean for your side length? What do you do the area to get the side length? Take the square root of the area. If your side length is y, what do I do to get the area? Square my side length. And this is what's really important, taking a look at if my area is 16x squared units. And I want us to make sure we have this one written in our notebook because we're going to have similar problems like this, but they're going to get more confusing. So I know what I want to do with my area to get my side length is take the, that's right, take the square root. So I'm going to take the square root of 16x squared. Because these are being multiplied together, I can rewrite this as the square root of 16 times the square root of x squared. Now I'm really happy this is the square root of x squared because they are inverse operations of each other. However, I need to rewrite 16 to have a square so I can take the square root. 16 is the same thing as 4 squared. So now I can cancel out my squares and square roots to get 4x. Now I know that might seem simple and easy. We didn't have to show all that work. But again, we're going to start using more complicated numbers. So if you can understand this, you can apply those skills to the more difficult numbers. Okay, so let's take a look at slide 16 and slide 17. Taking a look first at slide 16, the square root of 625. When you're looking at 625, you might not know already what 625 is if it's a number times itself. If I look at 625, I always want to think of a biggest number possible that goes into it. I think of quarters, 25. Oh, and it ends up being 25 times 25. So this is the square root of 25 being squared, which is 25. To show your work, you always need to show a number being squared to undo square roots. Let's take a look at 17. If I take a look at 17, this is the square root of 25 times the square root of 100. We can break these up into the 2 factors. So taking a look here, what's the square root of 25? Well, we know 5 squared is 25, and we know 10 squared is 100. If you cancel out the squares and square roots, you end up with 5 times 10, which is 50. Your final answer. I know we've gone over some of these, or maybe not, but I do just need you to be aware of how we're getting these answers. Let's keep going. Slide 18. When we take a look at slide 18, I notice we have decimals. Remember, when you're multiplying just any decimals in general, if I have 0.02 and I'm multiplying by 0.005, when you're multiplying, you add up how many decimal places you have, 2 here and 3 here, to get the final number of decimal places in your answer. You're going to end up with 5 decimal places here in your answer. So thinking about this, we have 2 numbers times itself equaling to 81. And both of those numbers need to have 2 decimal places because 2 plus 2 is going to be 4. You can also think about, since you're taking the square root, you're going to have half the number of decimal places. Or a number of decimal places divided by 2. So this is the square root of 0.09 being squared. Now we can apply our inverse operations to know that this is 9/100. Awesome. Let's take a look at slide 19. Take a look at slide 19, 20, and 21. Please pause the video for 4 minutes while you take a look at 19, 20, and 21. Please pause the video for 4 minutes. Okay, let's see how we did for 19, 20, and 21. And please, if you're looking at other slides, can you please go to slide 19 with me so we can go over these together? I greatly appreciate it. So taking a look, we have the square root of a to the 4th times the square root of b squared. We're okay with this b factor because square roots and squares are inverse operations. But remember, we need to rewrite a to the 4th as something to the 2nd power. Well, power of a power, this would be 2. Notice I'm not changing a to the 4th, I'm just rewriting it. Times square root of b to the 2nd. They cancel out, and you get a squared times b as your final answer. Again, your final answer is a squared times b, a squared b. I want to put these in alphabetical order as much as possible. Let's take a look at slide 20. Taking a look at slide 20, we want to take the square root of 1,296, and we want to take the square root of x to the 6. So again, you cannot use your calculator to figure out the square root of 1,296, but you can use it to be like, 20 times 20. That's too small. 25 times 25. That's too small still. You can also make a factor tree here if you need to. But I'll let you know that this ends up being 36 being squared. And let's think about how I can rewrite this x so it's being squared. X to the 6. Well, power to a power, you're going to multiply. So something times 2 equals 3. Oh, that's something times 2 equals 6. So that's going to be 3. So notice square roots and squares cancel each other out. So you end up with 36x cubed for your final answer. Nice. Let's take a look at the next one. Again, I like to break up my factors. Square root of 49/100, square root of x to the 8th, and square root of y to the 1st. Well, I know 49 is 7 times 7. Since there's 2 decimal places here, the square root is each going to have 1 decimal place. If you look at x to the 8th, how can I rewrite this to the 2nd? What times 2 gets me 8? 4. Can you simplify the square root of y? Can you do that? Nope, you can't. You just have to leave it as square root of y. So let's see. Square roots cancel out, so you have 0.7, 7/10. Square roots and squares cancel out, so you have x to the 4th. And you can't simplify square root of y, so that just stays inside your radical symbol, and this is your final answer. Notice a trick we can think about is dividing the exponent by 2, if possible. And that's an important thing to remember. So we're going to divide the exponent by 2 if we can when we're taking the square root. So let's take a look at slide 22 and 23. Taking a look at slide 22. Does the square root of a plus b squared simplify to the a plus b? Explain why or why not. Well, we can think about this as what's in here would be the side length of a square. A plus B. A plus B. If those are the side lengths, wouldn't the area be A plus B squared? And to go from the area to the side length, wouldn't you take the square root of A plus B squared and get A plus B? So does the square root of the quantity of A plus B equal A plus B? Yes. Yes, it does. Another way you can think about this is by substituting in numbers. So let's substitute in 3 for A, or let's do 2 for A and 3 for B. So taking a look here, this is saying if you take the square root of 2 plus 3 being squared, does that equal to 2 plus 3? Well, order of operations, I do what's inside here, so I get 5 being squared, square root. These would cancel out, and you're left with 5. Equals 2 plus 3, which is 5. Why, yes. Yes, this does. Well, let's continue and look at the next slide, slide 23. Does the square root of A squared plus B squared simplify to A plus B? Well, this is saying if we have a square, that A squared plus B squared is the side length. So what's the area? This would be A squared plus B squared being squared. Is that the same thing? If I take the square root of A squared plus B squared squared, I get A squared plus B squared. But here, you're not taking the square root of A squared plus B squared squared. You're just taking the square root of A squared plus B squared. So I'm going to say no. And then let's look at this with variables. If A equals 2 and B equals 3, this is saying the square root of 2 squared plus 3 squared is equal to 2 plus 3. Well, let's see. Order of operations, let's do our exponents. 4 plus 9 equal to 2 plus 3. Square root of 13 is 5? No way. Square root of 25 is 5. So I, again, have proved that this is a no. This is not a true statement. Awesome. Great work. You have reflection number 2. You have reflection number 2 for this notebook entry. Please get ready to start your next lesson, which is going to be 5.2c extension, dealing with meatballs. Thank you again. Do your best to be nice to everyone, and let's move on to our next lesson for today.